that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm Chris, and this is NASA Now. So how do satellites stay in orbit? And what's the difference between a geosynchronous orbit and a polar orbit? Well, we'll talk to an expert who will explain the use of each kind of orbit and how it works. That's ahead, but first, here's what's happening at NASA now. Update. NASA's Messenger spacecraft, which has been in orbit around Mercury for over 6 months, is sending back information that has revolutionized the way scientists think about the closest planet to the Sun. For decades, scientists have wondered whether Mercury has volcanic deposits on its surface. The answer is yes, and in a big way. New data shows a huge area of volcanic plains surrounding Mercury's North Pole, covering as much as 6% of the planet's surface. Scientists will use data gathered by Messenger as they continue to piece together the origins of our solar system. Now, let's take a look at the past.
December 18th, 1999, Terra, the flagship of the Earth Observing System, was launched from Vandenberg Air Force Base in California. Terra is the Latin word for Earth.
It is estimated that there are around 1,000 satellites currently in operation around Earth. Each of these satellites has been put into a specific kind of orbit depending upon its mission. So how does a satellite stay in orbit? And why are satellites put in different kinds of orbits at different altitudes? Joining us is NPP satellite project scientist Dr. James Gleason from the Goddard Space Flight Center. Hello, Dr. Gleason. Tell us about the different kinds of orbits.
A geostationary or a geosynchronous orbit is an orbit around the equator where the satellite orbits at the same speed as the Earth. So it has the effect of staying in the same place all the time. If you're looking for short-term, time-varying things, hurricanes, tornadoes, fires that might be changing quickly, you want to be staring all the time at one spot. If you're trying to understand the global picture, what's going on in Asia, what's going on in Africa, you need to make those observations. And for that, you need a polar orbiting spacecraft, which is an orbit that goes over the poles.
What affects the orbit of satellites?
The Sun-Earth distance changes as the Earth goes around the Sun. So small changes in the gravity field and small changes as the gravity of the Sun affects the spacecraft makes it push slightly out of its observing time orbit.
So currently you're working on the NPP project. Tell us about it.
NPP is a mission that is designed to make sure that certain advanced measurements are continuously made to help us understand the Earth, weather, and climate. Starting in the 2000 time period, NASA flew several research satellites which demonstrated the effectiveness of making a large number of environmental observations. These observations have proved their worth over the intervening decade, so much so that we feel the need to continue those measurements.
What kind of orbit is NPP going to be in?
NPP is in a polar sun-synchronous orbit. And what that means is it's a polar orbit, which means it goes around the poles, and sun-synchronous means it flies overhead at the same spot on the Earth at the same local time every day.
So how does NPP stay in orbit?
The orbit is maintained with fuel on board. So it's essentially, as the orbit begins to drift, which means that the time of observation changes slightly, we use a little bit of fuel and push it back to where it should be.
Why are satellites like NPP important?
One of the things we're trying to understand is essentially the entire Earth system, which is very complicated and has a number of systems that all interact. And then we try to take a step back and say, is the entire system changing? And is that important? And if it is important, what should we do about it?
Did you know that the NPP satellite weighs 4,600 pounds? That's about the same as a small school bus. Now you know.
Now, it's time to check out what's up.
There's no better way to get a bird's eye view of Earth than from satellites in orbit. Check out this NASA website called Earth Observatory. You'll be amazed at what you can see.
Now that you know how satellites stay in orbit, here's a chance to conduct your own experiment.
It's called Around the World, and it's easy to do right in your classroom. You can find this activity on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Join us next time when we examine high-tech survival on the International Space Station. See you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.